Hi and welcome back to my YouTube channel. As you can see, all the stepper motors are now connected to each driver. No, I have not as yet tested them. I've been fiddling around with my 3D printer trying to get good print but fast as well. So some parts are good, some parts are not so good. This looks good from this side but not this side. So I've tried different types of settings to do the print. And suddenly today also the nozzle got clogged. Luckily I had a spare nozzle, so I just replaced it and removed what was remaining of the PLA from this one. And yeah, so what you see in the background here is where I'm gonna mount the first stepper motor, being this one. The good thing is that I found schematics, etc., for all of the stepper motors, which is great because then I can really just focus on um, making the base for it, each arm part. I have to do it in different parts. Everything has to be one part connected to another part, etc. So if we just go take a look at the base plate here now, this one will go on top of the stepper motor. What you see actually is being this way. Believe it or not, I have not been working with Fusion 360 previously. I've been using FreeCAD. So yeah, it's a bit new to me, all of this. So let's just take a look. Two squares you see, the most inner squares with the holes for the bolts, screws will go. And I will make it so it will go up a bit. It will not just be a hole, it will be more like a rectangular hole, so to say. I want that because I need to, either if I'm going to use a timing belt or if I'm going to use a gear, I need to be able to adjust it so it either touches it or doesn't touch it at all, to get it in the right position. And also then I could, if I want, to just place the stepper motor directly beneath. However, I don't want to do that. I want some how should I say it, some torque from the stepper motor to the first part that gets to move. So think of the robot arm as a yeah, like an ordinary arm. So this will actually be the shoulder. Then it goes to the first part of the arm, and to the second, etc., to the wrist. From the wrist, then you have whatever tool you would like to put on it. And just what I'm trying to figure out is how I'm gonna go about this, because yeah, I could use a timing belt. Uh, the, the downside of using a timing belt is that they wear out after time. You could use gears; they also wear out after time, especially if you have plastic gears. I'm trying to get my hands on solid steel gears or similar to use in the robot. So yeah, okay, let's see if we can make the holes. Ooh, it's upside down now. Twist you around, so, and go like so. Okay. And all right, so I think the hole is around 4 point, what did it say, 4.75 millimeters. I don't have a digital caliper, so we just take an ordinary caliper and just measure. It would be almost millimeters in diameter. So we put it, since this screw, the bolt here is around, say, 4. Make the hole, say, I don't know, 5 millimeters in diameter. Just make it rectangular. Let's see if we can just put this. Darn it. And yeah, so okay, we go to oh yeah, I have to figure out how to make a hole. Can okay. Oh yeah, so we can create an arc. So okay, let's this first part here. I don't know how to do an arc on this one. Never mind. We just do like this. If I make one more down here. Somehow I think it would have been better just to, yeah, of course, place the. So, okay, now we have 4 holes for the first stepper motor to be installed. What we want is to make from this point, but forward a bit, so about around out here. I don't know if just do like, I don't know. I think this is something I need to look up first before I do anything, man. I like a challenge, so okay, let's just place a line here. I'll place first point, we'll place it there. Oh, you know what? Since its hole will be 5 millimeters in diameter, if you take the radius of it, it will be 2.5. So, perhaps the smart thing would be to let's see here, and then I move 2.5. Yeah, and then we move. Uh, okay, that couldn't be done. So okay, never mind. What the fuck? Oh yeah, well, hang on a second. No, no, wait a minute, wait a minute. Nah, I think I'm doing it wrong. Let's just let's just think for a second. If there arc, 3-point arc. Make a center tangent. Uh, Center point arc. All right. So oh yeah, yeah. This is the way we do it. Gotcha. Look now. So now just pull this one all the way down here to this. I mean, could even go a bit further out, see down like this if I want. And yeah, we want to do that. Yeah, yeah, yeah. So we go so. Okay, let's see here. We put it there. Now I don't need to really do. I can just so, and then I go back to create. We do the. So I put this one here. Oh, hang on a second. Uh, oh yeah, it can't move. Oh, hang on a second. We will have to do this again. Uh, so we center point arc. Okay. Yeah, 90 degrees. So ah, that didn't go well. No. Damn it! I need to think. Uh, why doesn't it work now? Perhaps if I continue from. Oh, oops. Continue from up here and just continue down. So we continue the arc instead from here, and I think that would be easier. Well, hang on a second. Now get. Uh, you need to look here with center point arcs. This would be the center actually. So See, do a 90-degree turn, and et voila. So, uh, let's see. Okay, now they're not on the same spot even. Helvete också. Uh, okay, so now we can do go back to the arc and do, let's see here. Alright, I'll come back with how this should be anyway, so I have to fiddle around with it a bit. Okay, see you next time.